J'ai une bonne présentation pour vous. J'ai Catherine Proulx. Elle est une chercheuse pour la Conseil national de recherche Canada. I have no idea what this means, but it's some cool Canadian department, which she might tell you a little bit about. I'm especially excited to have Catherine here because she was actually a speaker last year. Yeah, she did a great job. She probably presented the most beautiful professional CFP that I've ever reviewed. I help out with a bunch of conferences, and I was blown away. I was like, we're just taking her talk. And we got her back again this year. So please give her a huge round of applause. Catherine Proulx.
Hi, I'm Catherine. As James said, I'm a researcher. I also happen to be the daughter of a researcher. My dad is a sociologist. So growing up, we would routinely talk about power dynamics and cultural clashes over the dinner table. And that is surprisingly helpful when you're a nerd trying to survive the school bus. I would highly recommend knowing a bit about sociology. But that has also been very helpful in my tech career because it led me to realize that you can have a perfect software development process from a technical point of view, and it can still be a complete failure if you don't take elements of culture and sociology into account. So today I wanted to present a case study of the transition we've been going through at my lab, the Simulation and Digital Health Lab of the National Research Council of Canada, and to explain a bit how we've been going through that transition, more from the cultural point of view. I hope nobody is going to be flabbergasted by our technical solution. It is pretty much 90s style DevOps. But I think our bit of innovation comes from the fact that we did try to really take culture into account so that we would get a process that really matches the needs of our researchers. Before we get started, I would like to do a little show of hands. Is there anybody here in the room who is actually a researcher? Yes, we have one, at least. Has somebody been a researcher in a former life, maybe in grad school? Yes, some. And do we have people doing DevOps for researchers or working for researchers? Great, OK. For the benefit of those who haven't raised their hands, I'm going to give you a little profile of what it means to be a researcher. And I don't generally like to stereotype people. But in terms of researchers, research is a very, very homogeneous culture for many reasons. The first is survivorship bias. If you don't have certain traits, you're just going to be terribly miserable in research. But it's also a culture that is pretty tightly knit and that defines its own rules. Everybody in research goes through a fairly standardized process of going through grad school and then postdoc and a tenure track position. So it's a very standardized career path. And it's also a culture that self-regulates itself through peer reviews and granting processes. So it's going to encourage really an archetype of somebody who's going to really succeed as a researcher. And that person is somebody who's generally very single-minded about a very narrow topic. And also somebody who's really not afraid of making things explode. As a researcher, if you're not failing 90% of the time, you're not working on the right problems. So if you're trying to convince a researcher to adopt a process based on stability or certainty, it's not the right carrot for them. They don't care about things blowing up. And they're not going to believe you as well, because nothing can take the uncertainty out of research. That's the nature of it. Researchers also have a deep, deep hatred for red tape, more than your standard software developer. And that is made worse by the fact that researchers work in highly bureaucratic environments. Most researchers are either in universities, research institutions like mine or large companies that can afford to invest in research. And those institutions, for valid reasons, most of the time, have structures and red tapes and procedures which, from the point of view of the researcher, are just something that prevents them from doing their work properly. If they could get away with all that institution, they would do much better research. So if you come to them with a new process, they're going to be waiting for you with pitchforks because you're not the first of them to bring a process that is just going to make their job worse. Research is also a very individual endeavor. We are rewarded for our individual contributions, and there's some level of backstabbing involved in determining who's going to be first author and who's going to be last author. So it's tough to align those individual objectives with the goals of a software development team. And the bad news is that trying to manage researchers is like trying to herd kittens. You have absolutely no authority over them. Even if, in theory, you're the boss, the researcher's goal is not to advance in the hierarchy. It's to publish papers, or even better, get on Découverte. And nobody ever appeared on Découverte because they made nice Gantt charts. So if you're trying to nudge developers towards some kind of processes, you're going to have very little carrots and sticks to nudge them. The problem is that we still need some level of structure to do software. Even if you're a researcher in software development, most of what you do is general software development. We still need to wrap APIs and do UI and solve bugs and all the things that a good software developer does. For all my talk about researchers being free spirits in the pursuit of the truth, we live in the real world where there are security issues and people we are accountable for our results and the way we use the funds that we receive. And if at some point you want to commercialize the outcome of your results, you cannot just throw code around and be a free spirit. You need to get something stable with a nice framework. And we know as a software development community kind of how that works. The problem is, and if there's just one thing you remember from my talk, is that if you try to squeeze researchers in a structure that wasn't designed with them in mind, you're going to have very disgruntled kittens. Even if your structure is really, really nice, if you don't involve them in that process and you don't make sure that the process matches the way they work, you're going to get nowhere. And they're going to start blaming resistance to change and bad faith when actually it's a cultural clash. If you're lucky, people are just going to sabotage your process or find ways to work around it so that they still can do their research. And if you're not lucky, they're going to be in good faith and they're not going to innovate anymore. And nothing is going to happen in your lab. So what I wanted to talk to you is a project that we call Be Well. It has been my baby for the past 3 years. And it's a virtual reality based tool for helping people with cognitive issues. So we use it both for assessment and remediation, so essentially trying to cure cognitive problems. And we work with a range of populations, from kids all the way to old people, and several pathologies, including attention deficit disorders, depression, all kinds of cool stuff. And it is a very large-scale project. We have partnerships with major research hospitals throughout Canada. So we've reached a point where we cannot just throw code around and hope that it works. We have clinical studies and serious partnerships relying on that project. When I started 3 years ago, we weren't really not at that stage. It was essentially a tiny prototype living on somebody's machine. We had no process at all, no deployment. We were essentially running in the Unity editor. Nobody ever compiled. And we had a team that had very little software development experience, no Unity development experience except for myself, and in general, little production environment experience as well. Those were researchers, not software developers. I also work in the government of Canada, so our IT can be a bit complex. It's centralized, and we have very little control over the tools we can use. And there are also significant issues about using cloud-based tools because we handle sensitive data. So it makes DevOps a little bit more complex. And that is entirely normal. For a project at that stage to have no infrastructure, it is a normal state of things. It's how it should be. Because we do a lot, 90% of what I do fails. So I want to make sure that a project has enough potential before I start investing in its infrastructure. I've seen people fail out of grad school who had perfect frameworks with 100% code coverage, but who never published anything. Because they were not putting their energy at the right place. So it's normal in research for your infrastructure to grow organically along with the maturity of your project. And that's how the project has evolved over the past 3 years. We started with no deployment at all and no partners either, so that was all right. And the first thing I tried to implement is to have a well-documented manual process, basically what we would have done in 1998. Let's write it down in a procedure. The problem is that I was the only one aware of that procedure. And since it was a pain in the ass to follow, nobody did. And we ended up sending a version to a customer that had issues, and nobody was able to tell on which machine it was built, with which revision of the software, which VR system it was supposed to support. So we were we had our hands tied. There was not much I could do to support that customer. So quickly, we came to a point where it became clear that we would need a decent build system. Having absolutely no time to do a build system, nobody is assigned to DevOps. I did what every software developer should do. I stole 2 hours of my project, and I wrote a script. And that may not be, I mean, it is not the best build system ever. It is literally just a couple of lines of code that check out, run the tests, compile, make an installer, copy it on the network. But it does work. And one thing that's important in research, but in many other environments as well, is to realize that it's a lot harder to change a culture than to change a tool. I know that this script, we're very close to the point where we're going to outgrow it. It's still working with absolutely, well, very little maintenance, but we're getting to a point where we're going to need a real build system, and especially not something that builds on my development machine. But changing that, once we've gotten people used to the idea of having a daily build and to the concept that you don't send anything to a customer if it's not an official build, that was a huge cultural shift for us. And that shift was a lot harder to do than it's going to be to change to a different build system once we've reached that point. In terms of testing, like everybody, we started with absolutely no tests. And quickly, I decided to put in place a test infrastructure. I come from medical devices, and I come from a role of testing at Unity. So for me, that was really important. So we started putting in place automated tests, or I started putting in automated tests, but I was the only one writing them. But slowly, it was getting people used to the idea of having tests, and that it wasn't that big of a deal, and that it could be useful. So one by one, I gained over the researchers And we started getting everybody running automated tests. And when issues appeared, we would tell them like, oh, did you write a unit test to make sure it doesn't happen again? So organically, we were able to grow our test coverage and also to get resources from the rest of the team to act as part-time testers. In terms of process, as I said earlier, we started with no process whatsoever. When we were lucky, people were putting bugs in the Excel sheets. The rest of the time, they were just using Post-its and little bits of papers on their desks. And coming from the world of medical devices, I felt it was essential to get really a nice traceability of issues from requirements all the way down to testing. And this was a surprisingly hard sell because before my time, before I joined NRC, somebody had tried to push a bug tracking tool on the researchers. And it was a tool that was designed with a much more traditional software development workflow with managers doing triage and then sending that to developers who would send that to testers. And in a team where everybody's a researcher, pretty much on the same hierarchical level, and where there's no such process, it was getting very cumbersome for people. So what I told them is, let's put in a tool. It's just going to be sitting on a server that we own, that's on the side of that room, and we're not going to have any workflow. It's just going to be exactly like your Excel sheet, except issues are going to have a unique number, and we're going to be able to trace them. And I told people, like, don't worry. If it doesn't work, we're going back to the Excel sheet. We're going to get that tool in, and it's going to have to prove that it's useful. If you don't like it, just tell me, we're going to go back. And with some reluctance, people started using it. And slowly, we were able to start using more of the features of the tools. Oh, there's a feature for planning a roadmap. Maybe we could start having our iteration planning in there. Maybe we could start using the estimated scope of the feature to start getting an idea of what our backlog looks like and if it's realistic to do that much in our next iterations. So we were able to get to a more controlled workflow, but very organically, and always letting people know along the way that it was okay to come back to the way things used to be if it wasn't serving research. And like I said, there's nothing impressive in the tools that we used or the workflow that we used. But the impressive part is that we are now releasing every 6 weeks on the clock software that has very high quality with practically no need for customer support because it just works to our clinical partners. And our clinical partners are able to run clinical studies and it just works for them as well. And also the team is feeling that they own the tools, they own the processes, they have been part of that, putting them in place, and they can change them if they need to. And the important thing for us is that we are right now getting scientific results. We are publishing papers. Our partners are getting ready to publish. We're presenting at conferences. So our infrastructure and our DevOps is supporting the work we should be doing. So to summarize a bit what I've been saying, I wanted to end up with a couple of tips on how do you manage kittens. And most of you are not working with researchers right now, but I'm fairly certain that most of you know some kittens in your teams, people who have that kind of free spirit, don't hinder me with processes attitude. And if you just chalk it down to resistance to change or bad faith, and you don't think of it in terms of a cultural clash, you're going to have a hard time managing them. So my first take-home message would be start with the simplest thing that's going to work. The simplest, cheapest thing that's not going to require a committee, that you won't have to ask purchasing about, or that's not going to involve any security issues. Get the simplest thing that's going to meet your need and put that in place. And make sure that you can revert back if people don't like it, if it's not efficient. Let people know, like, this is a pilot program. We're going to give it a try, and if it doesn't work, it just doesn't work. That's OK. Also, don't try to repair the research process. Research is going to have uncertainty built into it. So if you're hoping that your process is going to make research predictable, that you're going to know exactly what are you going to release, when are you going to release, it's not going to happen. It just doesn't. If somebody asks me, how long is this going to take? Often the honest answer is anything between 2 hours and infinity. Maybe it's not going to work. Maybe it's scientifically impossible, and I won't know until I try it. So if you try to force people into doing something that is predictable, they're going to lie to you. And they're going to get really cynical about the process you're putting in place because they know they've lied to you in the estimates. So try to make sure that your process doesn't hide that uncertainty and that is able to handle things that explode and things that don't work as planned, because that's what research is supposed to be. At the same time, don't assume that people know what a good DevOps structure work looks like. If you have started your career in a well-run software team, you'll know that a good infrastructure helps you do good software. You have had the chance to experience it and see how smooth things can work if your DevOps infrastructure supports it. But if you're a researcher, chances are you've never experienced that. Most people go straight from their PhD, where infrastructure was a complete mess, to a lab context where infrastructure is still somewhat of a mess. So you have to give them the chance to experiment with good DevOps and let them come to their own conclusions as to what tools serve their research and what tools don't. And then if you have a good idea of what the end game looks like, you have to let them come slowly to that end game on their own, because that's just how researchers are. And finally, you really, really need to always keep in mind what your researchers' goals are. Your researchers don't care about your percentage of code coverage or the length of your iterations or how many bugs there are in the database. What they care about is how many publications I'm going to get this year. And am I bringing in revenue from my research? Are my research partners happy with what we're doing? Are we supporting new clinical studies? And if your DevOps is not supporting that, it's not doing what it's supposed to be. Because ultimately, nobody cares about your DevOps. What they care about is what those DevOps are supporting. So make sure that the work you're doing is always serving the research and not the other way around. So in conclusion, I wanted to thank, first of all, my dad, who vetoed this talk and made sure I wasn't saying anything stupid about sociology, and my girls, my two favorite clones, who made all the illustrations and would kill me if I didn't mention them. So any questions?
You have lots of time. You can.
Yeah, well, I told you, 19 minutes, straight on the dot.
All right, so first, let's just thank Catherine for a great talk. Huge round of applause. We actually have a small typo in our schedule, so we have even a few more minutes or an earlier lunch. But please, I want to hear some questions first. So line up at the mics, and in the meantime, here's a present for you.
Thank you. My clothes will like that.
So Julia has a child who does some nice drawings too, so I think there's going to be a draw-off after. I like Wu-Tang, and her child drew me a Wu-Tang symbol. Come on, let's hear some questions. Who's got a question for Catherine? Julia? Somebody? You're all shy. Come line up to the microphone over there. We got a question. I can bring the mic around if you have a question too. Just raise your hand.
Questions can be in French as well.
Non. Enfin, OK. Je suis juste curieux, de quelle façon vous utilisez la réalité virtuelle pour soigner des gens qui ont de la dépression? Est-ce que c'est des images d'éléphants roses? Non, mais quand je l'ai vu, ça m'intriguait. Je me dis comment, c'est juste par curiosité.
Oui, en fait, on travaille sur la composante cognitive de la dépression. Ce que les gens savent moins, c'est que les gens qui sont atteints de dépression grave ont aussi une partie cognitive qui est affectée. Souvent, les gens vont dire « Ouais, il est moins sharp. Cette personne-là, me semble, c'était quelqu'un qui était sharp, puis là, soudainement, la personne est moins sharp. » Donc, on travaille sur les gens qui sont en dépression grave, mais qui sont en situation d'emploi. Puis on essaie de voir si on est capable, en les mettant dans des environnements challengeants, donc des environnements où ils ont à répondre à des tâches cognitives, mais avec des situations de stress, on est capable de leur montrer à utiliser leur stratégie cognitive, leur stratégie de gestion de l'anxiété, gestion de la dépression, pour améliorer leur performance cognitive. Puis si la personne qui est en situation de travail est capable de performer au travail, ben c'est un gros atout pour passer par-dessus la dépression aussi.
Ah, intéressant, merci.
So, is it working? Yeah. So I'm one of your kittens because I'm professor of software engineering. And one of my questions is, I truly appreciate that you're talking about culture, but it's like, it's not, to me, DevOps is here to support a product delivery at some points, and my role as a professor is not to build a product. It's to advance science, to build prototypes, proof of concept, but if it goes to a product delivery, it will be through industrial partnership or those kind of things. So my question is more like, the content of your talk is for a special kind of research that people working with like clinical studies where product development is really important, or do you think you can generalize to like any kind of research, even outside of IT?
Yeah. I think it does generalize. It really depends on what kind of research you're doing, but I think even in an academic setting, if you want to go far with your research, there's a minimum of framework you're going to have to keep from one student to the other. If everybody is reinventing their logging system, each of their own for each of their PhDs, you're not going to get anywhere. Like, there's no value in a PhD student reinventing the UI or reinventing the logging system. You need some level of infrastructure. It's probably going to depend on how mature your project is. At NRC, we're very much focused on industry transfer of our research. So that makes it a little bit, we're probably a little bit further on the need for infrastructure scale. But I think even if you're doing research that is more exploratory, that's not going to have anything commercialized at the end, you still need some level of structure to be efficient and not have people just get tangled in resolving bugs and not know, like having just a mess of a code that you just throw away and restart from scratch for the next student because it's not workable. Does that answer your question?
Yep. Thank you.
And I think like even in universities, there's more and more of a focus towards being able to transfer that knowledge to somebody else through commercialization as well.
Yeah, which makes sense. But the main point, as you said, the fact that there are some breaks and that applying a DevOps whole pipeline can slow down the research process because you're tied to follow things that are more driven by publications than industrial transfer. It really depends on the orientation of the labs, for example. So yeah, makes sense.
Yeah, if your DevOps process is slowing down your software development, it's not the right process for you.
Thank you.
We have another question.
Yep. Hi.
Hi.
Thanks for the presentation.
You're welcome.
So I also work for the government, so I really appreciated hearing about all this. I relate very much. So right now I'm like DevOps in Environment Canada, but I was also a technology teacher. So I'm wondering how training sort of relates to this cultural shift you're talking about, because you may have noticed that often in government, the people who do training are completely non-technical. And then what happens is the people who are completely technical but have no teaching experience end up doing the teaching. So how does this training sort of, like, I don't know, do you have any tips or stories on how to put that all together?
Okay.
Like, instead of getting the wrong people to do the wrong things, maybe.
Okay, I would say, in our case, well, I'm certainly hoping that people coming out of a PhD that we are hiring would have at least experienced some level of DevOps in their career path until now. I'm hoping that universities would pick up part of that training bit, even though people are not necessarily software developers. They might be like biomedical engineers or something else. But I'm hoping that people working with software in the context of their studies should have a minimum knowledge of how DevOps works, because that's still their tool. In the real life, people coming to us generally have very little software development experience. So we do it through mentorship mostly. I've been mentoring people who are not software developer by trades. I generally have people read basic textbooks about software development, just so they know what language we're talking. They know really the basics of, like I said, 90s style software development, because that's where we started with. And I try to let people come to their own conclusions, let them fail a little bit, and then they're going to be a lot more open to learning other ways of doing things. But it's tough. And I think when research labs are able to integrate people from the industry with more of a production background and researchers, it makes things a lot easier for training.
And have you had any success or luck with finding support from government services, like, you know, internal government of Canada,
we can
School of
take
Public...
that offline.
Yes.
Is that my polite answer?
We're almost out of time. If
Okay, well,
the
thanks a
gentleman
lot.
has
Thank
a
you.
really 30-second question, you can go really quickly.
Yeah,
Sorry.
quick question. How big is your team, and how long it took for everybody to change their culture?
Okay, our entire lab is 30 people. I would say a third of that is software developers. The rest has a very mixed background, either biomedical engineering, mechanical engineers, chemical engineers, who have come to this through other pathways. And the cultural shift is still taking place. I've been on that project for 3 years. It's been a very slow transition. I am often chafing at the bit and hoping that we would put things in place faster. And it's not always working as fast as I would like, but I'm expecting that it's going to take another 3 years at least before we get to the point where I'm happy with our DevOps structure.
Thank you.
Thank you very much, Catherine. Let's hear a huge round of applause. Let's hear it, Catherine Proulx.